That's it. Does calculus make you go to the hospital? L'Hopital's rule. The l'hospital. Yes, it's some French mathematician it is named after. L'Hopital. Some limits cannot be found using algebraic methods. That means direct substitution, and just so it's on record, a limit is a substitution problem. And it's when substitution doesn't give us an answer that makes sense, is when we have to use other techniques. Yay! L'Hopital is a technique. So, when you substitute in, do you see 0 over 0 or infinity over infinity? Those are all called indeterminate forms. Why? Because when you divide 0, what's nothing divided by nothing? It's not clear. Or what's infinity divided by infinity? Again, let your mind wrap around it. But it is not clear. And when something's not clear, it's indeterminate. Yay. So this is called L'Hopital's rule. And it may help you find the limit. So there's the definition. In that, do you see that when you take the derivative, f prime at g and so on, that it allows you to re-substitute in, but now using the derivative. And as long as you get the indeterminate answer of 0 over 0, infinity over infinity, you can reapply it as many times as you want. That means take the derivative, until you get the answer. And we already talked about, we're talking about which one increases faster, right? That allows us not to keep going all over and over again mindlessly. All right, let's look at number 1. Wait, I saw number 1 before. I saw number 2 before. What? I don't get it. No. I already taught you this, right? If it's approaching infinity, look at x over e to the x. Which one's increasing faster? That means the answer is what? 0. That's it. That's simple. Now, L'Hopital's rule says if you plug in infinity to the top and bottom, it is in the right form, infinity over infinity, which means you could take the derivative, and the derivative of x is 1, and the derivative of e to the x is e to the x. Now you can clearly see the denominator is increasing faster. What's happening as you put in large numbers? In other words, we don't have a variable anymore, right, to even think about, right? It's just a constant, 1 over whatever. You can see this is approaching 0. That's using L'Hopital's rule if it's not obvious. Obviously, I see it is obvious that the top is increasing slower than the bottom. How about number 2? What's the answer? It is. Why is number 2 going to infinity? Because e to the x is increasing way faster than just x. And over time, it's going to go to infinity. How about 3? What's the answer? So first, don't get into the habit that the limit's always approaching infinity, is it? No. Ultimate limit is what type of question? Substitution. So what happens if I plug in 0 for x? Does it actually give me an answer, or is it 0 over 0, which is indeterminate? I like how your brains work. First it started 0 over 0, and then the brakes went on, and they said, wait a second. So if you plug in, it's actually 0 over e to the 0, which is really 0 over 1, so the answer is actually 0, using substitution. Why do we use these other techniques? Is when direct substitution fails us. 4. What's the difference between 3 and 4? So what should the answer be? If the limit exists, that means from the left and right should be the same answer or not?
Yes.
Oh, is it the same one? Let me back up. It's actually e to the x over x. What happens when I plug in 0? This one's actually undefined because it's 1 over 0, not L'Hopital's rule. L'Hopital's rule is 0 over 0 or infinity over infinity, positive or negative. If it's 1 over 0, not L'Hopital's rule. So what's another way I can get the answer? Use your calculator. Why not? You could also graph it, do a table of values, see what's happening as you're putting in smaller negative numbers approaching 0? What answer did you get? There you go. So, obviously you know, or maybe you don't know, but at 0 there's an asymptote because it's undefined there. So you'd actually see a vertical asymptote that goes over 0. And it's an odd one. What does that mean that it's an odd vertical asymptote? That the exponent on x is odd. What does that mean? On one side it's going to heaven and the other side is going the other spot, right? It's going way up and way down. So obviously on the left it's going to negative infinity. What would the answer be to the right without using a calculator? Just hit a plus sign. Good. So does the limit actually exist at 0? No. In case you're going to get the answer wrong. So the answer here was? So again, if you graphed it and there was at x equals 0, there's an asymptote. On the left, it's going which direction? And on the right side, what direction is it going? The exponent on x is odd. It's an odd asymptote. So that means they go in opposite directions. If it was an even exponent on x, they would both go up or both go down on either side. All right, 5. Step 1, don't assume. What limit is x approaches what? 0. A limit is what type of question? Substitution. Sure, plug and chug. Can you do that first? Don't even do it right. Go underneath, right? Go 3, take away 3 to the 3 times 0 over 0. Simplify it in your brain. What do you get? 3 times 0 is 0. 3 to the 0 is... Oh, I forgot the e. That's important. So e to the 0 is... And then 3 times 1, or negative 3 times 1. If you simplify it, is that the form of using L'Hopital's rule? Yay! What is L'Hopital's rule? Don't forget the limit notation. It will be wrong on the quiz on Thursday. What's the derivative of the numerator? What is the derivative of the numerator?
Negative 3e, 3x to the log of 3 times 3. Right?
What did you say?
Negative
The derivative of 3 is,
0.
and e to whatever is e to whatever, right? So it's negative 3e to the 3x times, what's the hook? No, lon. Derivative of the exponent, which is 3, and then derivative of x is 1. Now we can do the same thing again. What does that mean? You plug in 0 and see what does it equal when you plug in 0. So e to the 0 is 1. Negative 3 times 1 times 3 is negative 9 over 1. Wow, that's beautiful. We're done. So what's the limit as it approaches 0? And the answer is negative 9, right? And that's when it approaches 0, we're not using those rules of which one is increasing faster. So when do I use L'Hopital's rule? When you substitute in and it's infinity over infinity or 0 over 0. What is L'Hopital's rule? Derivative of the top over the derivatives of the bottom, and then do it again. Plug in, and if you need to, you can reapply it as many times as you need. Look at number 6 and 7. This one's more challenging because it's going to negative infinity, right? So then we're looking at left-end behavior. Now we're not looking at which one's increasing faster. We're looking at the other side of the graph. So this is L'Hopital's rule would be more helpful here. What happens when I plug in negative infinity? What does the top go to? Positive infinity. What does the bottom go to? Remember, a negative times a negative is So it's also going to where? Because e to the positive infinity, right? So they're both going infinity over infinity. So what does L'Hopital's rule say I can do? What's the derivative of the numerator? What's the derivative of the denominator? Negative. Well, first of all, it's e to the negative x, right? And then what's the derivative of the exponent? Beautiful. Now what happens when I put in negative infinity? The top, if you put in negative numbers to infinity, the top is negative infinity. What's the bottom? Remember, a negative times a negative is positive, but that negative 1, what does it make it? So now it's negative infinity over also L'Hopital's rule. So now what can I do again? We stop when it's clear what the answer is. What's the derivative of 2x? The bottom is negative e to the negative x times negative 1. Obviously, the negative times the negative, just so it's very clear, is positive e to the negative x, correct? So what's the answer now? As the numbers get very small, if you plugged in negative 1 billion, if you plugged in negative 1 trillion, what is this answer getting closer and closer to? Yes. But only one person really felt confident to say it. If I plugged in negative 100, the negative times the negative is positive, right? That's 2 over a huge number. As I put in larger numbers, it's going to be 2 over a bigger number, and 2 over even a bigger number, and 2 over even a bigger number. That number is getting closer to 0 as it's going along. It's a fraction. The top isn't changing, but the bottom of the fraction is getting bigger and bigger and bigger and bigger and bigger. Well, if I said 1 over 10, 1 over 100, 1 over a billion, what am I getting closer to? 0. That's what this is explaining, right? And you have to think some number sense, right? To see where it's going to. One more here. 7. What's the first thing you should do for number 7? What? Okay, what is that? Well, let's see. Let's see. Let's see. Some of you guys are still sleepy from the weekend. Took a big old picture. Calculus is number 18 on your list in your brain right now. Not that high? 18 is too high of a number. I can think of more than 17 things that are on the top of my brain. Calculus is down for a little further down. Ha! Hey, what's ln 1 without your calculator? That's right. Take away 1 plus 1 is, in 1 squared take away 2 plus 1. Is this a candidate for L'Hopital? And what does L'Hopital mean? It thinks take the derivative. What's the derivative of the top? Yay! That's it, right? And the bottom? Don't even make it look prettier. What happens when I plug in 1 now? Use your brain. Use your brain. Plug 1 now. Use your brain. What is it? You plug it in and guess what you get again? So can I do it over again? Do you see it? When you plug in 1, it's 0 over 0 again. So now what do? Do not forget the limit notation. On the side, you can do your substitution, right? And if it's right, then use it. But if it's not, then you have to go back. Use your limit notation. What's the derivative of 1 over x? Remember, 1 over x is the same as x to the negative 1. So the derivative would be negative x to the negative 2. That's it. And then the denominator would just be what? Now what would you plug in? Good. We're done. Just tell me what the answer is. What? What? What did you say? Plug in 1 and tell me the answer. That means we're done. Like it's this, but tell me what the answer is. If you really wrote it down that way, you would get full credit. It makes me sad to know you can't simplify it. 1 to any exponent is equal to? So it's negative 1 over 2. Done. Thank you. Boo. Staple button. Over and out, Mr. G Math.